Welcome. We're about to break down the must-know credit analysis models for your Level 2 exam into a super clear visual guide. All right, let's just jump straight into it. We're skipping any kind of formal agenda to get right to the good stuff, the high-yield content you absolutely need to know for exam day. Okay, first up, we're going to conquer learning outcome C. This is all about calculating a bond's expected return when its credit rating decides to, well, move around. Think of this as your roadmap, your step-by-step guide. We start with the bond's rating right now. We look at all the possible ratings it could have a year from now, and then we crunch the numbers to get a single probability-weighted expected return. It's a really logical flow. So here's how you actually do it under exam pressure. It's a simple, repeatable three-step process. First, for every possible rating change, you calculate the price impact, the hit or the gain. Second, you look at the transition matrix they give you to find the probability of that change actually happening. And third, you just multiply and sum everything up. That's it. It's a system. Okay, let's really zoom in on this formula, because there's a classic trap here. See that negative sign? It's so easy to forget when you're rushing. But think about it. If a bond gets downgraded, its credit spread gets wider, right? So that spread new minus spread old part becomes a positive number. Multiply that by your negative modified duration, and boom, you get a price drop. It has to work that way. That inverse relationship is everything. And this is where it all comes together. We're taking all of those potential price changes we just talked about, weighting each one by its specific probability, and then adding them all up. What you get at the end is the single best estimate for the bond's return, taking into account all the uncertainty around its future credit reading. Pretty neat, huh? All right, this slide is gold. It's your how not to lose points guide. Forgetting that negative sign? Classic mistake. The examiners will also try to distract you. They'll throw in a bunch of extra data like YTM or coupon rates just to see if you get flustered. Don't fall for it. All you need is duration and the spreads. You should absolutely expect to see this exact type of calculation on the exam. Okay, great. So we've nailed what happens when a rating changes. But now let's take a step back and look at the bigger picture. How do we even try to predict a default in the first place? That leads us straight into our next section and learning outcome D, comparing the two big types of credit models. The whole difference between these two models really just comes down to one simple question. Are you trying to figure out why a company defaults, or are you just trying to predict when it might happen? Keep that why versus when idea in your head, because it explains everything that follows. And this table here is basically your cheat sheet. On one side, you've got structural models. Think of these as the academic models. They're all about the why. They use balance sheet info to explain the economic reason for default. On the other side, you've got reduced form models. These are the trader models. They don't really care about the why. They're all about the when. They use observable market data and stats to predict the timing of a default. Let's create a quick mental picture for these structural models. Just imagine that the shareholders own a call option on the entire company. The company's assets are the underlying, and the debt they owe is the strike price. Simple, right? So if the assets are worth more than the debt, they exercise the option. They pay off the debt and keep the difference, which is the equity. But if the assets are worth less than the debt, they just walk away. The option expires worthless. That's the elegant idea behind the famous Merton model. Okay, another crucial slide here. The number one trap on the exam is mixing up which model uses which inputs. Just burn this into your brain. Structural models rely on the firm's total asset value, which you can't see, it's unobservable. Reduced form models, on the other hand, use things you can see, like market prices. So if an exam question starts talking about using observable market data to predict defaults, you know right away it has to be a reduced form model. All right, let's pull all of this together. We're going to put everything we've just covered onto a single, powerful dashboard that you can use for your final revision. And there you have it. This is your one-page summary. Take a screenshot, jot it down, do whatever you need to do. On the left, you've got the key formulas for calculating return from rating migration. On the right, the 4 critical distinctions between structural and reduced form models. If you only have a few minutes to review this topic, this is the slide you look at. So I'll leave you with this final thought, which you can see right here on the screen. Which model do you think holds up better when the market gets crazy and volatile? And how does that affect your analysis? Thinking through that kind of what-if scenario, applying the theory to real-world stress, that's what's really going to make the difference for you on exam day. Best of luck with your studies.